State how a polarized transverse wave differs from an unpolarized transverse wave. The oscillation of a polarized transverse wave is limited to a single direction in a plane that is perpendicular to the direction of propagation of the energy of the wave. The oscillation of an unpolarized transverse wave is in all directions in a plane that is perpendicular to the direction of the propagation of the energy of the wave. Light is polarized when it passes through a sheet of material known as Polaroid. The component of the displacement of the wave in the direction of the polarization produced by the Polaroid is unaffected as the wave passes through the Polaroid. The component normal to the direction of the Polaroid is completely absorbed by the Polaroid. Two sheets of Polaroid P and Q are placed close to each other. Their directions of polarization are parallel to one another as shown in the figure below. A parallel beam of light passes through Polaroid P. The beam after passing through Polaroid has amplitude A and intensity I. The beam then passes through Polaroid Q. For the light transmitted through Polaroid Q, state the amplitude in terms of A. Okay, the amplitude is the same. The intensity is the same. And the relation between answers 1 and 2, intensity is the square of amplitude. The Polaroid Q in C is now rotated about the axis of the light beam as shown in the figure below. The plane of Polaroid Q remains parallel to the plane of the Polaroid P. The angle between the direction of the polarization of Polaroid P and of Polaroid Q is theta. Complete the table below to show the amplitude in terms of A and the intensity in terms of I for angle theta equal to 180 degrees, 90 degrees, and 60 degrees. Now, unpolarized light, when it passes through Polaroid P, it will be parallel to the axis of polarization of Polaroid P. So this is polarized. So it passes through Polaroid Q, which is parallel to the axis of Polaroid P, then the entire wave will pass through. So the amplitude will be A. So this is the amplitude is A after passing through P. For 90 degrees, the polarization axis of P and Q is perpendicular to each other. So after passing through P, the light will have axis of oscillation parallel to the axis of polarization of P. Okay, the light has a zero component along the axis of Q, therefore no light will appear after passing through Q. When the angle is 60 degrees, the light after passing through P will be parallel to P. And the component that is of this light that is parallel to the Q is given by A cosine 60 degrees. So this is the direction of the light. So this is the orientation of Q. So there is the component of the light that is along the axis of Q is A cosine 60 degrees. Cosine 60 degrees is 0.5. So the amplitude is 0.5 A. Intensity is square, so 0.25 I. So 0.5 A whole thing square will be 0.25 A square, and A square is equal to I. Hence, sketch the graph of how the intensity I changes with angle theta. So we know that the intensity is I, at 90 degrees is 0, at 60 degrees 0.25. So that is the intensity versus angle graph.